Welcome. Thank you for coming. Thank you, Jay, for lunch.
Yay.
Uncle Weedy is really Mr. Uncle Weedy, my boss. He
We
takes
always appreciate it.
We'll tell Mr.
Sorry,
Thank
you
you
guys
on your
online
behalf.
don't get to enjoy that. Just as usual, a few things to note. The next meeting, February 19th, will not be here. If you're online, out of state, you will not be able to attend because we're doing a tour of Channel 7's new facility. And I can't show that to you guys, sorry. We're gonna all have to sign some kind of NDA. So I'll start getting emails sending out tomorrow. And if you do want to come, I'll send you the form. They need everything a week prior. And then we'll figure out lunch over there somehow. And then of course, good turnout here. Everybody in here who's an SBE member, you will be entered once you attend 2 meetings. So this will be the first meeting. Every meeting you attend in person will give you the opportunity to next year, 2026, when the SBE membership comes around, we'll do a drawing actually at our holiday party this November. Eric won for us to pay for this year. But yeah, we'll buy you a SBE Members Plus membership, which is a really great membership that they have. Anyway, I think that's about it. Jay's distracted. Anyways, thank you guys for coming, and I'll hand it over to Jay.
Okay, we sure that's your meeting? That's it? Okay. All right. I gotta stand up. We actually built you guys a really nice demo, and to go along with our PowerPoint, we did have a show and tell, but unfortunately, half of our equipment is somewhere at your FedEx facility, which I spent an hour at this morning trying to pick it up. So what we're gonna do is we're gonna talk about interoperability for anybody using Wheatstone, Axia. You want to merge into your 2110 network. You want to move into your Dante network. All of this is possible. You know, when you look at all these emerging protocols, and you know the popular ones are WheatNet, Livewire, Ravenna. Those are for what broadcasters. You know, the Dante stuff now comes into broadcast, more live audio, commercial. The TV guys really like it. The first 3 I mentioned were pretty much all the same stuff. You can take WheatNet, take just a word sync, not a PTP clock or anything, but you can come out of an X node at 48, come into a Wheatstone, sync your Wheatstone system to your Livewire network, go in and out of Livewire and WheatNet using quarter millisecond streams. Do the same thing with Ravenna. If you want to do things without hardware and you want to use computers and everything, we can't really use live streams or quarter millisecond packets. And at that time, we usually revert to AES 67. And at that time, we need to do a PTP clock. When you want to bring Dante into our broadcast world or into our environment, they make it difficult. You know, they're much bigger than all 3 of our companies combined. And I will say that about Dante. All this AOIP stuff started around the same time, early 2000s. They've done a really, really, really good job of getting that protocol out there in the live environment and the commercial environment. It's a little bit easier to use, but the application's different. Most of the Dante stuff is unicast. It's point to point. They're not taking a codec here and sharing it around a whole facility. So the first 3 protocols I talked about, the WheatNet, Livewire, and Ravenna, are all multicast. So that works really, really well for broadcasters. For things that are going to change on the fly and you want to be able to route anything anywhere, that works really well. So one of the things that we want to talk about is, you know, you want to pick an epicenter. You want to pick a system that you're comfortable with, you like to manufacture, and it's usually one of the big 3. Where we see things like 2110 in our environment, we see Dante and AES 67. It's great to reach out to those certain devices and bring them into whatever core or whatever environment that you're using. And at that point, you're still using your existing system and you're using these other protocols to reach in and out, bring codecs in, telephony stuff in and out. So when you want to look what we're calling like a unified AOIP network, there's about 7 practices that we've outlined together, and I'm going to bring them up one at a time, and then Kelly's going to discuss from the user standpoint. So my colleague today is Kelly Parker. He was a systems design engineer at Wheatstone for 14 years. He started out with Bonneville and Susquehanna, California. Then he worked for Wheatstone for the last 14 years. Then he was director of engineering for Town Square's 375 radio stations. And so it's been awesome working with somebody for 14 years. Then he went to your side of the business, learned a ton about networking. How many studios did you build? You know, rolled out WheatNet everywhere, but he's going to be speaking from experience today because he was at Town Square. He was putting in SoundFX master clocks. He was using VX phone systems with WheatNet, you know, central core. So he's the guy who's been bringing stuff in and out of these systems. And we don't see a lot of it, but when things are getting old, people are moving, stuff is changing. You get to build a broadcast facility once. And that's really when we're seeing a lot of this happen. So for you guys that are moving into new houses and stuff, you know, you might be moving in with TV. You might want to say, how do I get, you know, audio and video together in and out of the Wheatstone system? So the first thing that you have to do with these systems is you've got to get them all on a master clock. Okay, when you have WheatNet right now, it's our metronome. It runs around. It does all the clocking. If you're like an old TDM house, like the Entravision team, they got our Wheatstone bridge router. You know, that thing creates its own clock. And one of the things that the first thing you have to do when you want to bring Dante or you want to get on 2110 or you want to get into like VX is you pick a master clock. So Kelly will take a few minutes and discuss master clocks. They're not all created equal. And one of the limitations that we've seen with them is how many devices you can hang off. So I'll let you take it from here.
So yeah, they're not all created equal. You can spend as little as $500 and get something very basic to put on a small network, or you can spend many thousands of dollars doing it. You can buy the typical one, kind of middle of the road, couple of $1,000. That'll get you a SoundFX. They have a couple of different versions. There's an oven controlled crystalline one that'll give you like 0.1 parts per million for timing on it. And the one that's not, will give you about once it'll drift maybe a second over 115 days, something like that. And then on the non-oven crystal, I think it's a drift about a second every 11 days. It depends on the accuracy you want, what you want to do. These PTP clocks will typically act in, you can put several of them. They use a media domain to decide where they live. So you'll have those in, you can have them in different media domains if you want for different gear, but they all synchronize. It'll pick the best one, the most qualified master clock if you have multiple, so you can't put redundant ones on the networks. It just really comes down to how much money you want to spend. In TV, your guys are always willing to spend more money. So you're doing things like everts and stuff like that, where in radio, we don't have that kind of money. So we spend a couple of $1,000s, and that's still expensive for radio stations. So that's the key to it. But it really comes down to money and the number of devices that hang off them. As Jay mentioned, a lot of them are limited on that. So a SoundFX will do about 25 endpoints on one of their clocks, and then you start to get dropouts, and it'll fall off. So as you pick that, you just want to make sure that you're looking at the scale, the size of your network to pick the clock that you want.
How many times in a native WheatNet do we send out packets, timing packets?
Typically, it's like every 5 milliseconds. The metronomes are going out.
Yeah, and so when you think about that, and if anybody's been dealing with AOIP, you know, I always joke because I say it's gremlins on your network and your bandwidth is food, because it is really, really traffic intensive, and it's not the audio, it's the timing, it's our clock, and that's all Ravenna is, that's all WheatNet is, that's all Livewire is. They're just a clocking scheme. The payload, the audio is all the same. It's how we move that audio and logic through the whole system. So literally, if you are planning on using AES 67 and Dante and any of the other systems, the first thing you do is have to have a master clock. That's something that Wheatstone never decided to take on, is building a master clock. If you guys use Axia Livewire, you can actually, in their X node, the version 1 and number 2, it will act as a master clock. So when him and I built our demo, we brought a SoundFX clock, but if you have X nodes, you can use those as a master clock. They're just limited to, like Kelly said, about 10 devices you can hang off them. But if you guys are going out in OBs or doing remotes or something like that, and you've got some Dante stuff, or you're going to go to a TV station, remember that that stuff can act as a
That's
master.
also gonna be a floating clock. It's not gonna be GPS synchronized. So
Yeah.
that's one of the other things, if you care about that. In a small environment, you won't really care about.
So once you start everything, and now Kelly's going to talk to you about PTP and what PPT does.
Okay,
Okay.
here we go. I kind of covered some of it. So PTP is going to send out the clocking packets to keep everything in sync. So in a Wheatstone system, one of our devices, what we call the clock master inside, takes that PTP information and then puts it out in metronomes for the rest of the WheatNet products. With Dante devices and Ravenna devices and Axia devices, it takes that PTP clock. So you're going to keep in mind how many of those devices are talking to the clock that you have. Again, a Sonifex will do about 25. So you need to keep that in mind, and you need to have additional clocks or boundary clocks. And that can be done in switches or other devices that a lot of manufacturers make. So again, and none of the manufacturers, unfortunately, us and all the others, nobody's really put together a good solid clock like program or a policy or good practices. Nobody's really developed a great thing. You're kind of on your own. I mean, we have recommendations, but it makes it really tough not knowing your environment. So
yeah, all this AES 67, everything are committees. They're groups of people that are trying to come up with standards. And just like everything else in our industry, it moves really, really, really slow. So there's a lot of recommended things you can do. But if I think you guys said you're going over to Channel 7 next week. Yeah, they're probably doing a lot of 2110. And the facilities that we are working with 2110, some of the bigger TV groups are said, yeah, we've got one. We're not doing that again. It takes a lot of expertise. All right. And when you start doing AES 67, we designed stuff from the ground up. When you open up a blade, it's easy to name. And we've done that because it's our architecture, it's our protocol, it's our audio transport running on our hardware. So we've got lots of control. So when we were developing WheatNet, oops, let me turn that down. When we were developing WheatNet, development was really, really fast. The minute we started having to do AES 67 stuff and doing interoperability stuff, it slowed way down. Very similar to IBM early in the computer industry. When you wanted an IBM, it was called an IBM solution because they did everything. And then when they had to stop and sort of adhere to standards, it slowed their development down. But one of the things that is doesn't matter what, you still got to have a core. So once you pick your master clock, you know how many devices that you're going to have on this network, and you got to decide this network. Now you start needing building spreadsheets, whether it's Google Sheets or Excel, because you're going to have, when you get into these other devices, you've got lots of addresses and things that you need to keep track of. And then you need to pull those addresses in and out of whatever core system so it can recognize it. If I take a Wheatstone box and plug it into a switch, all of our other boxes are going to see that, all of our other software, because we have discovery. And that is something that eventually we're working towards. But right now, when you connect Axia to Axia, it knows what it is and it talks. That's one good thing. And some people call Livewire or WheatNet or Ravenna proprietary. I don't know. It sort of is proprietary, but it works. And at the end of the day, when we look at like a Dante solution, you've got a blue box, a red box, a green box, and a yellow box, and a really nice white Cisco switch or nice switch in the middle. And when somebody rolls out an update and something stops working, definitely the networking stuff is a lot more troubleshooting. You need a different set of tools for it, and you need a lot of expertise. So I will always say, yes, you can do lots of interoperability and do things with other manufacturers, but for your own sake and support and reliability, pick something you know and you trust, and then you use these other protocols going out. But once you've, like I said, you've picked your clock and now you get your devices, now you've got to set up your infrastructure. I've got clients right now that can't program a simple Cisco switch to work with blades. When you get into the other stuff, it's another level. And then I'll let them talk about this, but what you're actually doing now by step 3 is you're integrating. You're not putting a system in, you're integrating several other things. And at that point, some customers might want to think of integrators. We're seeing more and more and more of things installed by integrators. Jason, you just had a project installed. You couldn't, it's like changing, you can't run a facility over here and build a new facility. So I always recommend, if some of this stuff is out of your expertise, call integrators or use them as a consultant. They're out there. And I'm gonna say they're younger because they're a lot younger than me, but this is stuff that they're dealing with. So yeah, it is. It's like, and look, unless you own a radio station right now, and you can't do it. That's okay. You can't do everything. Technology, I don't even know all my own products anymore. And so I can't expect you guys to know all of my stuff and the Zeta stuff and the wide orbit stuff. So some people are like, well, I shouldn't have an integrator. No, these guys are good at pulling in all these different technologies and making it work. So I'll let you continue, Kelly.
Yeah, the network infrastructure is key to this thing. This is not a place where you want to try to save money on your cabling, your switches. Don't buy cheap switches. I know we recently put a Netgear up on our website. That's their AV line. Yeah, we're not going to use that. I'm going to pull that down.
Yep.
So when you're doing stuff like, you need to use switches that do this well, QoS, IGMP snooping, queryers, things like that. And that's typically going to be Cisco and TV. You're going to get some of the Arista, things like that, the higher end switches, but those are way out of the price range for radio. But Cisco did a nice job putting a 9000 series together for radio broadcasters. But yeah, that's key. Don't skimp on the cabling. Don't go buy the bargain cable that got put on sale from there. Don't do that. It's going to bite you. Spend the money on good cabling, do it up front, get it certified up front, get your switches configured by an integrator or a professional that knows what they're doing, understands what's going on. And then you've got some recourse too if it doesn't work. And so if you're just guessing, that's a bad time to guess. So
yeah, and once you get I can tell you, once you get this infrastructure set up, it doesn't change. I've never in the history, we sold our first blades in 2008. I've never called up Cox in Tampa and said, you need to upgrade that switch I sold you. I've never called you and said, you need to update it. You never heard of it. You guys came out to Wheatstone for factory training. You never heard us mention that. The only time that I've told customers that they had to mess with their switch, it was when somebody bought a 3850 and 4 years later they bought another 3850 and those OSs didn't mesh. That's the only time I've ever recommended anybody upgrade anything for their AOIP network. So that's one thing that's nice, is that you get this thing set up and it's literally the George Foreman grill. You set it and you forget it. You keep IT out of it. Okay. You never need to upgrade it. They're not going to maximize it. And one of the biggest support issues for every manufacturer is the switches. You get somebody from Amazon, you get the best IT guy from Microsoft. They walk into this broadcast application and they see multicast everywhere. I've had probably 10% of our systems out there, somebody come in and turn off multicast because they're afraid of it when they're not used to it. But that's what we do to send everything everywhere at any time. And it is gremlins on your network and your bandwidth is food. You don't want to connect it to the office network. Your office network is going to do nothing with this. It's going to, there's
going to choke.
Yeah, and people do VLANs. I don't recommend it because I know something's going to change down the road and it's going to affect your audio program. And it could be anybody plug something in a studio edge switch trying to get on the internet. If you create a loop in any of these systems, game over. Get you 100% epic failure. You might as well unplug the Cisco switch at that point. But you want to be careful. And a lot of times we tell people, hey, put these switches in the broadcast racks. Don't put them in the IT room. Keep them away, because once you do set them up, and it's the same whether you're setting up for our stuff or interoperability, once you get the infrastructure and that fabric set up, pretty much leave it for life. Us manufacturers have recommendations on setting up other access ports for new devices and things, but very rarely, unless you're going to change the topology of the network. And that is, I've got a building here with a stack of switches here and edge switches. And now I want to connect to that building over there with fiber and add the stack. So that's where you might get back into it. But here's some of the things that we do, because you've got to configure every protocol. You have to touch it just a little bit different.
Because usually most of the manufacturers have documentation on what the requirements are for their stuff, and you have to figure out how to meld them all together in the switch to make that work. But it's usually pretty easy, and most of us are also willing to help when you need it. So
one of the things that we always joke about is from a manufacturing standpoint is manufacturers have recommendations for a reason. And one of the ones that I recently told the guys in Australia, because they wanted to use a different switch. And I'm in their corporate meeting with all these IT guys, way smarter than I am. And they're like, well, we need to move this to IT. We do this, we do that. And we use Arista switches, or we want to use Juniper because Cisco's too expensive and we don't want to use their, just there's a million reasons. And I said, well, when that guy calls our emergency support line in the middle of the night and he's either got a switch issue, lightning, or replacing a switch, my guys can ring off that configuration in their head from bed and get you back on the air in about 2 minutes. That's one of the reasons. And we have really good luck with it, but we do have recommendations. You don't have to follow those recommendations. Got a guy in South Africa that loves TP-Link. Okay? Loves them. And when I went down there in October, he's telling me, guys, well, every about 45 days, do you guys reboot your systems in America? I'm like, there's no power switches on anything with a Wheatstone logo. Why? Because they're using inexpensive switches. The routing tables fill up and they have to reboot them. I guess that's fine down there. That's not acceptable here. And one of the other things that when you get to these bigger systems, we've got in iHeart, Texas, Dallas, we've got 25 studios. They've probably got 30 switches through the facility. When they have a power issue, when it's a Mylar balloon hits the power line outside and the transfer switch doesn't work and everything goes down, we have really, really good luck with the Cisco coming up and joining pretty much all the time. Pretty much it's like 100%. And we do the same thing at Wheatstone. So pick your switches. As Kelly said, that is the last place. I've been watching this stuff on Facebook group lately, people wanting to use less expensive switches and everything. And I comments like, that is cabling, patch bays. And because you guys, what we're doing on these networks, Ethernet was not designed for what we're doing. We are putting, 50 packets in a 1-pound bag and trying to get it through the stuff. So, by nature, Ethernet is undeterministic. Okay, that's why we use the PTP clocks. We stamp everything. We know where everything is. So, this is.
Others work together, but
Yeah, and in the smaller markets, this is a big market, so some of this doesn't apply to you guys. But in a smaller market, they don't have an engineer, and it's a testament to our hardware. So a lot of times it just works, and it goes in there, and a new engineer comes in and he sees a switch and he connects it to the business network, and stuff still works. But lock these things down. Keep your broadcast stuff to yourself, because where you will have issues is when other people get in there. It's not like on the install, it's later. This is what makes everything work. The querying, and I'll let Kelly talk about this. This is what makes WheatNet work and Livewire work. And for you guys that have programmed those switches, there's a lot of QS settings and everything, but it's querying and snooping that makes them work.
This is the key, because not everybody supports QoS the same way, but IGMP filtering is the absolute bottom line to multicast working in an environment. So it's called Internet Group Management Protocol. So it's taking, basically it's a one-to-many conversion. So it's one source being sent to many destinations, and it creates a group on the switch, and then the other listeners that want to hear that source join the group on the switch. And that protocol is managing all of that. So the last guy out, the switch will say, hey, there's nobody else listening to this. Can I prune this group from the network? If nobody responds, switch prunes it from the network. That multicast stream has gone away until someone requests that audio again the next time. Yeah, that's the basics of it.
Yeah, and not all systems prune.
No.
So one of the things that this is just exclusively WheatNet. I'm going to take 2 minutes and do a sales pitch because they bought you lunch. We weren't the first. No, serious. What's really neat about us, and I'm going to give us some accolades for this, is because we saw the first systems come out there, the CobraNet, the EtherSound, and the Livewire. They were really chatty. They were doing this all the time. Okay, and then I'll be upfront with you. We looked at the Axia switch. He actually was an integrator before. I forgot to mention he was an integrator, and when we saw what it took to build an Axia infrastructure with all their settings, it was a lot. And they were making the switch do a lot of work because they were 100 meg devices. and it's multicast, so it was going everywhere. One thing, and that's how Livewire works, and unfortunately AES 67, because you've got a receiver out there always waiting for a sender or to receive a multicast address. One thing Wheatstone does is when it comes up, everything goes, hey, who wants me? And we call that dark mode. But when the system starts settling down and you've got a blade over here with 6 outputs, nothing routed to it, we shut those receivers off. So then your utilization of the switch gets really, really quiet. We're really neat if you use us across links, because in the Livewire world, if you've got an X node over here, you can turn off those outputs and limit the bandwidth from point A to point B. But it's really not a router at that point. So when you want to add something to the back, you got to turn those receivers back on. Our system automatically does it. So when you've got a wireless link or an IP radio, you can click on one source and you should see it go up about 5 meg. And then you click another source and you see 10 meg, because all these streams are about 4 point something. If you're worried about bandwidth with these IP packets, use 5 meg as your reference. That covers any overhead in for network conditions or bursts or anything like that. Did I leave anything out on that?
No.
That was your infomercial on Wheatstone. Almost to the dawn. So once, look, just because meters move from point A to point B, it doesn't mean it's good. That's one of the things that we've seen at our office all the time is, and we say it's like, we load code in something, we hit play over here and we see meters jumping over here. We're like, yeah, okay, headphones, audio precision. Just because the meters are there, it doesn't mean your audio is good or it's in sync or anything like that. It's yeah. So you got to really spend some time and you've got to look at these things. You've got to listen to them. You've got to power them down. You've got to power them back up. You want to make, so it's when it's not big when you pick a core system and you're using all the same pieces. It's when you start bringing all these different pieces in.
As you get to know it, you'll hear certain sounds on the networks, a type of click or pop or a stream overlap, and you'll start to recognize those over time. And it helps with troubleshooting. But the tools are getting better, but right now, Wireshark is one of your best friends on a big network like that. The other one, Mindberg, makes a PTP TrackHound, which helps with clocking, so you can pull that. It's a free tool that you can download from their site. So, but people are developing tools. There are hardware boxes that are super expensive right now to manage all of this stuff, but it's getting better, and the tools will come around just like it did in our AES and analog days. It's just not there yet, but they're slow. Everything is slow, like Jay said.
Yeah, it is. It moves slow. What software? So we've done some super big systems lately, and when you get over 30 or 40 studios, you've really got to start looking at switch to switch traffic. That's the only time you really got to start worrying about bandwidth. What is the tool that you're using?
I use Cacti that I'm monitoring every port, so I can look at the actual throughput on the switches on every one of our ports in our test system. So I can see what's going across that link at any given time. So that's a key test one. And then we use Wireshark a lot. We use PTP TrackHound and other stuff like that. There's a lot of networking tools right now.
Yeah, it's the world we live in.
And again, if you don't want to touch it, get yourself an integrator. They'll use all this stuff. They'll troubleshoot it. But that you're going to want somebody that has some network understanding and can dig into the switch configurations, understand it, and make sure it's all set up correctly.
And then ultimately you need to listen to it. Depends on the box. Our boxes are a millisecond latency, analog in to analog out. But then you got to go to a console. You got to go to the mix engine. You got to go out. You got to go to a headphone panel. So I'm telling you, if you've got
might add some EQ dynamics.
You've got a Dante red box over here, and it's plugged into there, and that's what I'm going to use for my headphone and my commentators. When you get done with all these steps, that last thing, it may not work. And there's nothing you can do about it except start reducing the hops. Some people start going in, and even if you went, it's really hard to do in radio to go in and out, in and out, in and out to make an audible difference between our stuff. But when you start going in different devices between all these different manufacturers, we use, back in the day, the biggest problem I saw in 1996 was Harris came out with a CD link that was 32K, right? And then we had 48K, and we had sample rate conversion. First of all, we had to have sound cards and all these devices and consoles all sync together. They had to be synced. Then God invented the sample rate converter. We did up conversion and down conversion. That was never an issue. Right now, what we didn't really get into is we've got eighth millisecond packets, quarter millisecond packets, 1 millisecond packets, and 5 millisecond packets. When you get into hardware like these boxes, eighth millisecond and quarter millisecond all day long, because we're using FPGA and fast processing, and it's done in native. But when you get into boxes like Kodak, anything with a PC in it, it doesn't have enough horsepower to do these quarter millisecond packets. So now you're getting to 1 millisecond packet and then 5 millisecond packets. So you've got to look at all that. Obviously, Wheatstone and Ravenna natively were all quarter. We didn't have a live stream and a not live stream. And we did that because latency. So that does catch everybody. It doesn't matter in your transmission. It just matters everybody that's talking into a microphone and listening to headphones. Once you get up, the number changes. I was always told 5 to 6 milliseconds. Some people say 10, you can start hearing the combing effect. I say anybody, we have like 3.5. And if you went from an analog console with headphones today and a microphone to our best IP system,
there are guys that can hear it.
They're going to hear it. So one of the things that you want to, when you're starting to build these systems and you think about interoperability, get the pencil out and just start doing some basic math to make sure it's going to work. And then when you're all done with it, document what you did. None of them are the same. He started off saying there's no standard. There's really no proper way to do it. We all have recommendations. But just like when you build a transmitter site or you used to punch stuff down to a punch block, document it for the next person. You know, it's because it's still not 100% all IT. You know, there's still broadcast smarts and stuff built into this. The next guy that comes behind you, it's going to be difficult for them. So
if you're a company that has multiple sites, try to get some consistency across that, because we all know we're getting smaller and smaller as an industry. We don't have the support around the country that we need. So when you've got a site that's unmanaged, if you know that site is exactly like any other site, it's much easier to troubleshoot and manage from a guy that's in it remotely. So just keep that in mind.
I'm not because you're here. One of the first standardizations and I've worked at Wheatstone for 29 years. It's been my only gig, and I've worked with a lot of the same customers for those 29 years. The first really product standardization that I saw coming out was when Crawford went to our first blades. We decided we were going to get off the bridge and we were going to use a blade and we were going to use UMix in the blade. And this man wrote a document, I still have it, that we sent to every single Crawford station. They all had bridge routers, but they were all moving to the Wheatstone blades. And this man did it, and then he documented it. Okay, you document it. But at that point in life, I could go to any one of your markets and speak somewhat intelligently about that migration path. Since then, you know, Bonneville, Town Square, iHeart did over 400 standardized studios. I like it if you're in that environment where you can do it, because then you can share expertise. We have all of Hubbard Radio except Cincinnati. So when these guys have a conference call and they're talking about rolling out wide orbit and SLIOs and starts and stops and how we're going to record and how we're going to set up scenes on the board, they've got one odd duck out there that has to sort of figure it out by himself. So there is a reason for standards. So any question on interoperability, guys? I did have gear to show you today. I'm sorry I didn't show up. Questions? Chris, you're doing a little bit of it here. Was it challenging for you at all?
It was. Just the, you know, it was on the leading edge of it. There was a learning, and it took a while to figure it out. And then it just, you know how it is, Kelly. You mess with it, suddenly it just starts working. Okay, that's not sure what I did. I'm not sure what I did, but let's write it down quick, you know. And there it is. And then, you know, later on it starts to make sense. A lot of it was, I didn't really have any control over what was coming out of equipment. Figuring out how to configure.
Yep. Yep, it's
part
sort of, it's a manual process still.
As part of your document, like a WheatNet system is gonna hand out multicast addresses based on the signals you define in it, but when you start bringing in Dante devices, Ravenna devices, external stuff, that's all manual, so you're gonna start having to document that, and those look like IP addresses, they're just a range of IP addresses that are multicast. You're gonna have to track that somewhere. Trying to do it in Navigator, you can do it, but it's much harder. So if you have a spreadsheet somewhere, some kind of documentation that lets you know what you've got out there, and you can glance at that and go, oh, I'm putting a new phone system in, I can use this range, and you've got something to cover that.
Sydney, Australia, ABC Sydney, they went live with a new 2110 newsroom, full 2110 newsroom. At the beginning, I said I had customers doing that. They have 500,000 multicast addresses to do that newsroom. Did you hear that? 500,000. That's for all the video streams and all the audio stream and everything it takes. And there's a program. Look, these are big public companies with, where their governments fund them. Yeah, but it is a manual process. I always say stick a core. I mean, you look at a Wheatstone system with 500 by 500 cross points. Okay, if you to mono that, and then you add all the utility mixers and then all the buses for the consoles, it's not uncommon to have several thousand multicast addresses in a standard little radio, because every bus, program, audition, all the mix minuses, aux, stereo masters, submasters. Yeah, any source, any mix. So yeah, so they get big. But once you get these things set up, they tend to run, and I don't care whose system it is. And for people in this room, when they call me and they say, Jay, something's not working, first question, what changed? What changed? And then we usually get to the root cause right away. And, it could be a power outage, something got hung, soda in a console. For some reason, they just don't come out and tell us that. That's one of the ones we've got to dig out of the clients. So, but don't be afraid of the interoperability stuff. Every one of the manufacturers I just mentioned, we all have knowledge bases on our website. Ours is getting better, but we have documents on there how to get in and out of Wheatstone, into Livewire, Dante, everything. Yeah. Yeah. So that's pretty much what we're going to talk to you guys about in interoperability today. After this, for people that want to stick around and do some Wheatstone training, we're going to switch laptops to Kelly's laptop, and he's going to log into our big system back home. We've done in a lot of, obviously it's just Wheatstone, but we've done a lot of changes in our architecture. We've upgraded Navigator. We've got new tools in our system, and then we also want to do a Q&A. So we're going to take like a 5-minute break. Well, any questions first? Anybody have any questions? I usually don't after I talk. No? A not sales pitch, but no. And guys, I do thank you guys for coming here today. I know it's a lot out of your day.